Welcome to the deep dive. We're your shortcut to getting truly informed on the stuff that
Yeah,
matters.
we cut through the noise for you.
Exactly. We focus on the critical info, aiming for those aha moments. Today, we're diving into, well, a scenario that's a real test for anyone managing high availability systems.
Yeah.
It's the kind of thing that really shows who knows their stuff in DevOps and cloud engineering, separating theory from, actual experience.
Battle-hardened experience, yeah.
So let's jump right in. Here's the specific question for today's deep dive. How do you calculate and interpret error budget burn rate for a service with a 99.99% SLO during a 15-minute Azure Zone outage, and what are the implications?
Right, that's a classic one, and it's super critical. Look, the quick answer, it's stark. A 15-minute outage on a 4.9's SLO service.
Bad.
It's not just bad, it's pretty much catastrophic.
Catastrophic.
Yeah. Basically, you'd burn through, like, months worth of your error budget in just those 15 minutes, not days, months.
No.
And it's not a small blip. It immediately triggers policy violations. Think release freezes, mandatory reliability work. It forces major architectural commitments to stop it happening again. It's a huge wake-up call.
Okay, multiple months of budget in minutes. That sounds almost impossible to come back from.
Let's really unpack this. For a lot of people, 4.9's, that 99.99% number, sounds great, but maybe a bit abstract.
Sure, it can feel that way.
Can you break down what that actually means mathematically for an error budget? What's the real-world impact?
Absolutely. So when we talk 99.99% SLO, we're dealing with mission-critical stuff, services where even a tiny outage hits the business hard.
Right.
So we quantify this with an error budget. Over a standard 30-day month, 99.99% availability means you only have 0.01% unavailability allowed. That's your error budget percentage.
Okay, 0.01%.
Tiny, tiny. Now, a 30-day month has 43,200 minutes, so you do the math. 0.0001 times 43,200. And your total error budget, your total allowed downtime for the entire month is just 4.32 minutes. Wait, let me get this straight. Less than 5 minutes for the whole month.
Less than 5 minutes.
Oh.
4 minutes and 19 seconds, precisely.
That is incredibly tight. How do you even track that accurately? It feels like you need second-by-second monitoring.
You absolutely do.
All
It
right.
demands that level of precision, sometimes even milliseconds. It just underscores the extreme reliability expected for 4.9's.
Yeah, no kidding.
You're essentially saying this service must always be available. No tolerance for unexpected blips. Teams have to engineer out every possible failure point before here.
Okay, that context is crucial. Now, you mentioned burn rate earlier, and you said that's where this scenario gets really interesting. Why is burn rate so critical, especially with something like a 15-minute Azure outage? What does it tell us that just knowing the downtime doesn't?
Right. It's definitely more than just the total downtime. Think of the error budget, that 4.32 minutes, as your allowance for mistakes for the month. The burn rate tells you how fast you're spending that allowance compared to a sustainable rate. It's about the velocity of failure.
Ah, the speed.
Exactly. Imagine a speed limit for errors. Burning at 1x means you're using your budget exactly as planned over the month, but 3x, 5x, you're speeding way past your limit.
Got it.
The calculation itself is, conceptually, pretty simple. You take your observed error rate and divide it by your allowed error budget.
Okay.
So for this 15-minute Azure outage, the observed error rate is 15 minutes divided by the total minutes in the month, 43,200.
Why?
That's roughly 0.0000347.
Right.
And we know our allowed error budget rate is 0.00001, so divide 0.0000347 by 0.00001.
You get a burn rate of 3.47x.
3.47x. Okay, what does that number really signify for a business, for the team? What's the story behind that 3.47?
Well, this is where it hits hard. A 3.47x burn rate means you use your budget allowance 3.47 times faster than you're supposed to.
Yeah, think about it. You're allowed to use 4.32 minutes over 30 days, nice and slow. But here, you burn through 15 minutes in just 15 minutes flat. That's an acceleration 3.47 times faster than your entire monthly sustainable rate.
Wow.
And, crucially, that single 15-minute event consumed 347% of your monthly error budget.
347%.
Yep. You didn't just spend this month's allowance. You went deep into debt. You've effectively borrowed against the next, 2.47 months of budget?
So you're starting the next couple of months already in the red?
Exactly, like maxing out your credit card way early and having nothing left.
Okay.
And for the business, it means immediate SLO violation. You broke the 99.99% promise.
Yeah.
Your error budget is gone. Zero tolerance left for any other issue.
No wiggle room at all.
None. And importantly, this isn't just numbers on a dashboard. It triggers real organizational pain, like immediate release freezes, no new features deployed, or mandatory reliability sprints, pulling engineers off product work to fix stability. It directly hits your roadmap and agility.
That paints a frankly terrifying picture. How one short outage can cascade like that. It's not just downtime, it's development freezes, trust issues.
Precisely.
So given that extreme sensitivity, what kind of architectural choices are non-negotiable for hitting 4.9s, especially knowing cloud providers can have zone outages? How do you build for that?
Right. Architecture is everything here. You have to assume things like Azure zone outages will happen. There's significant regional failures.
Yeah.
And 15 minutes. That's actually pretty typical recovery time, involving complex stuff like network fixes, service mesh updates, load balancer changes, DNS. It takes time.
Okay, so it's realistic duration.
Very realistic.
Yeah.
So to actually meet 99.99%, you need robust zone fault tolerance built in from the start. That means things like, well, first, synchronous data replication across zones. No data loss allowed.
Synchronous, okay, not just backups.
No, real-time consistency. Then you absolutely need automated failover. Detection and recovery under 30 seconds. Humans are too slow here.
Automated and fast.
Stateless service design helps a lot too. Lets you replace instances quickly without losing context.
Makes sense.
And implementing things like circuit breaker patterns, they isolate failures, stop one problem taking down everything else, like fuses in your house.
Got it. So these aren't nice-to-haves, they're foundational.
Absolutely foundational requirements for 4.9s. Serious engineering effort.
Okay, so even with all that great architecture, stuff can still happen. How do teams actually monitor and alert on this in production? You need to know instantly, right?
Instantly and intelligently, yes. You can't just page someone for every tiny flicker.
Right. Alert fatigue is real.
Totally. So most mature teams use what's called multi-window burn rate alerting. It balances sensitivity with noise reduction, like having different settings on your smoke detector.
Okay, how does that work?
Well, you set thresholds over different time windows. For example, maybe a really high burn rate, say 14.4x over just 5 minutes, that consumes 2% of your monthly budget. Fast, that's an immediate page. Urgent.
Okay, the house is on fire signal.
It's Gaelic. There may be a 6x burn rate over 30 minutes, using 5% of the budget. Still a high priority alert, means something sustained is happening.
Right.
And maybe the 3x burn rate over 2 hours, eating 10% of the budget.
Yeah.
That's a standard escalation, still serious.
I see multiple levels.
Yeah. And our 15-minute 3.47x burn rate scenario, that's nasty because it would likely trigger both the 30-minute and 2-hour alerts pretty quickly. It screams sustained high-severity incident.
Okay.
And once that budget is gone, like we said, the policies kick in hard, release restrictions, stop deployments, reliability sprint, fix the foundations, maybe even an architecture review or an SLO reassessment asking if 99.99% is even achievable or sustainable.
It's clear 4.9 is a demanding target. How does this 15-minute event compare across different SLO levels? Does the pain just scale linearly, or is it worse at the top?
Oh, it gets much, much worse, exponentially so.
Yeah.
This is a really key point. Let's just quickly compare that same 15-minute outage. For a 99.9% SLO, 3 nines, you've got 43.2 minutes budget. That 15-minute outage is just a 0.35x burn rate, uses 35% of the budget. Annoying, but manageable.
Right.
For 99.95%, the budget is 21.6 minutes. The outage gives a 0.69x burn rate, uses 69%. Getting tight, but still within the month's budget. Then our 99.999%, 4.32 minutes budget, 3.47x burn rate, 347% consumed. Boom.
Yeah.
And just imagine 99.999%, 5 nines. Your budget is less than 30 seconds a month. That 15-minute outage, it's a 34.7x burn rate and consumes 3,470% of the budget. It's astronomical.
Wow. So 99.99% really is that critical point where brief outages become absolutely devastating.
Exactly. It's the inflection point. The response has to match. For 4.9 services post-outages, all hands on deck. Incident commander assigned, customer comes out within 30 minutes, root cause analysis done in 48 hours, remediation plan within a month.
Intense.
And preventing it long-term means constant investment. Things like chaos engineering, deliberately breaking things in controlled ways, including simulating zone failure.
Assessing that resilience.
Yep. Enhancing observability for sub-minute detection. Fully automating recovery, zero-touch failover. And serious capacity planning, often over-provisioning, so the remaining zones can actually handle the load shift during an incident.
This deep dive really hammers home the engineering discipline required. It makes you think, what's the true cost of aiming for that ultra-high availability? Not just money, but the organizational agility you might sacrifice, the sheer architectural complexity, maybe even the toll on the teams.
That's a great question to ponder. So just to wrap up the key takeaways from our discussion for you. First, remember that 99.99% SLOs mean an incredibly small error budget, just 4 minutes and 19 seconds per month. It's razor thin.
Right.
Second, that seemingly short 15-minute outage. On a 4.9 service, it blows through 347% of your monthly budget. You're borrowing heavily from future months.
Deep in debt.
Third, hitting 99.99% isn't luck. It demands major, upfront architectural investment, multi-zone, automated failover, solid monitoring. You can't just add it later.
Foundational.
Fourth, running out of error budget isn't just a number changing. It triggers real policies. Release freezes, reliability sprints impacting your whole development process.
Okay.
And finally, remember that sensitivity to outages grows exponentially. As you push towards 100% uptime, each 9 makes even small problems vastly more impactful. 99.99% is a really critical, challenging tier. That's all for this topic. Stay tuned for the next DevOps Cloud interview question.